I'm Sarah Smith. I'm Edgar Basera.
I'm Prince Lawrence Saison.
I'm Christian Dante Pato, Resurrection Channel.
And we are
Group 3.
And we are here to present the Artino Project 13 Week Challenge.
AP13 Week Challenge. Step 1, Arduino. Step 2, jumper cable connected to Arduino. Step 3, relay pin 3. Step 4, button pin 2. Step 5, servo pin 9. Step 6, potentiometer connected to A0 and fan connected to ground.
This is the code of AP13 Week Challenge. Int relay pin is equal to 3, then semicolon, pin for the relay, then int button pin is equal to 2, then semicolon, this pin connected to the push button, and then int servo pin is equal to 9, and the semicolon is pin for servo, then int pot pin is equal to A0 is for potentiometer pin, then sharp include, then servo.h, int relay state is equal to high, then int button state is semicolon, then record the button state to record the button state, and int last button state is equal to low semicolon to record the last button state, and then long last debounce time is equal to 0 then semicolon, and long debounce delay is equal to 50 semicolon to eliminate the bounce time, and servo may servo semicolon, and then for the void setup, close open parenthesis, open curly bracket, inside is pin mode, close open parenthesis, inside is relay pin, comma, output, and the semicolon for relay control pin. The next is pin mode, close open parenthesis, button pin, comma, input, and the semicolon for the button input pin. And then pin mode, close open parenthesis, servo pin, comma, output, and the semicolon. And then digital write, close open parenthesis, inside is relay pin, comma, relay state, and then semicolon for relay off or fan off. Then my servo that's attached, close open parenthesis, inside is servo pin, and then semicolon. And the last is close curly bracket. And for the void loop, close open parenthesis, curly open bracket, inside is int reading is equal to digital read, close open parenthesis, this inside is button pin, then semicolon to read the value of the button. And then check if button is pressed low to high transition. If reading exclamation mark is equal to last button state, close open curly open bracket, inside is last debounce time is equal to millis, close open parenthesis, and then semicolon, then close curly bracket. Wait for 50 ms to evaluate if it's the time state as last state. Wait for 50 ms to evaluate if it is the same state as last state. Then differentiate the button state. And if the state button is high or press, change the state relay. Then if close open parenthesis, inside is millis, close open parenthesis, minus last debounce time, then greater than the bounce delay, curly open bracket, then inside is if reading exclamation mark is equal to button state, open curly bracket, then inside is button state is equal to reading, semicolon, and then if button state double equal to high, then open curly bracket, relay state is equal to exclamation mark, then relay state semicolon, and then three close curly bracket, and then digital write, close open parenthesis, inside is the relay pin, comma, relay state, and then semicolon, then int pot value is equal to analog read, then inside is pot pin is and then semicolon, then int angle is equal to map, close open parenthesis, inside is pot value, comma, 0, comma, and then 1023, comma, 0, comma, and then 180, and then semicolon. Then my servo.write, close open parenthesis, inside is angle, and then semicolon, and the delay is 10, and the semicolon, and for the last button state is equal to reading, and the semicolon, and close curly bracket.
This is the output of AP13 motor fan with challenge. In our challenge, we use the help of servo and potentiometer. By the help of servo, we can manually swerve or turn left and right by tapping the motor fan above the tip of the servo meter. And by the help of potentiometer, we can easily maneuver the turning of our motor fan.